Hello everyone, welcome to Nrcm and this is Shravani and I'm going to explain about operating system UNIT2 SJF, that is shortest job first and priority scheduling algorithms. So we'll go into the SJF slide. So SJF is the shortest job first algorithm. And it is the best approach to minimize the waiting time, and here actual time taken by the process, it is already known to the processor. See, coming to the example, so as we discussed in the previous class, like if the process should be executed, if the process should be executed, all the process should be stored in the, they'll be coming and sitting into the ready queue. Okay, so in the previous class we have discussed about the FCFS also. Okay, in the previous video, if you want, you can check that video. And here this P1 to P4, the process, all the processes, they are in the ready queue. They are waiting in the ready queue for execution. So how this SJF will select? So it will select the shortest job first. So here all the processes are waiting. So they have come, they are waiting in process. P1 is there, 2, 3 in the ready queue up to 4. So it will check the shortest job first. What is shortest job? What is the meaning of shortest job? So the job is nothing but the burst time. The process P1, it wants how many milliseconds to execute a program? It wants 6 milliseconds, and P2 wants 8 milliseconds, and P3 wants 7 milliseconds, and P4 wants 3 milliseconds. Means burst time or the jobs, these are the jobs which have to be performed by the processes by using the CPU. Yes, okay. So it selects the, as the name itself indicates, shortest job. So if you consider the burst times of all the 4 processes, which is having the lowest burst time, that is shortest burst time. So that is 3. Okay, so the 3 is related to, the job is related to process P4. So first initially this P4 will be executing. The P4 will be allocated the CPU for execution. Okay, and so next after completion, how many milliseconds it wants? It wants 3 milliseconds. So it has started at 0th millisecond and it has ended at 3 milliseconds. Okay, next compared to like 6, 8 and 7. So which process is having the shortest job? So next process 6 is having the shortest job, means lowest burst time. So here and the process, if you check the process is, process related to 6 is P1. So now the P1 will be allocating the CPU. The P1 will be allocating the CPU, or P1 gets the CPU for executing the program. Okay, and what is the burst time for P1? How many milliseconds it will be busy with the CPU? So it is 6 milliseconds. So already we have, so 6 milliseconds is like 6 plus 3. So total it wants, completion time will be 9 milliseconds. So now we have completed process P1 and P4 execution. So the remaining process in the ready queue are P2 and P3. So within this P2 and P3, which is having the lowest burst time or shortest job? So P3 is having the shortest job. So next third P3 will start executing. P3 will start executing, and it completes, and it starts execution at 9th millisecond. It completes execution at by 16th millisecond. So I'm just taking the example of milliseconds. And next last remaining process in the ready queue is process P2, and whatever the execution time might be there, so this process P2 will be executed. Okay, and the average waiting time, if you consider what will be the average waiting time for the I mean, not what will be the average waiting time for different process. For process P1, it is 9 milliseconds. Okay, average, the waiting time for process P1 is 9 milliseconds. Until 9 milliseconds, it is, sorry, it's not 9 milliseconds, it is 3 milliseconds. So until 3 milliseconds, the process P1 did not get the process did not get the CPU. See here you can see at 3rd millisecond only the process P1 got executed. Next coming to the process P2, the average waiting time is like 16 milliseconds. 16 milliseconds for P2, because at the 16th millisecond only the process P2 has got executed. And next, the average waiting time, the total waiting time for P3 is, where is P3? So P3 is, it is 9 milliseconds. At 9th milliseconds, the P3 got the chance, and the waiting time for P4, P4 is 0. At the 0th millisecond only, the P4 started executing, or it has allocated the, I mean, the CPU has been allocated to the P4. So these are the waiting times for each different processes, and with the help of these waiting times, you can calculate this average waiting time. So I mean, the main disadvantage, so as you can read here, is like, if you want to, the algorithm, I mean, if the programmer want to implement this SJF algorithm, so he or she, they should be knowing the execution time of the job should be known before the execution only. Okay, and here, or we can say like this, execution time should be fixed. You cannot change the execution time. So after changing, like if P4 has already been executed, suppose its execution time, or if its burst time is increased to like 5 or 6, then it is not, I mean, here it is not, in such cases this SJF algorithm will not work. Okay, so it is little difficult to implement. In case of execution time is not known earlier, it will be little difficult to execute this algorithm, implement this algorithm. Okay, I hope you all understood. So next we are going with the priority scheduling. So what is priority scheduling? So priority scheduling is a method of scheduling all the processes which are based on the priority. Means based on the priority levels, the process will be executed. Priority is like, the meaning of priority is like importance. Importance, based on the importance, the operating system, or you can say the scheduler, will choose which process to assign the CPU. Okay, so here consider these all are in ready queue. P1, P2, P3, P4 up to P5, they are in ready queue, and for each process they have given the priorities. Okay, for process P1 priority is 3, P2 is 1, P3 is 4, P4 is 5, and P5 is 2. So they have given the priorities. So in this example, we'll consider the priorities, means the numbers we are considering from, the 1 is having the highest priority, and 2 is having the next priority, 3 is having the next priority, in this way. Okay, else sometimes you can select like 9 is having the highest priority, or next 8, next comes 7. So it depends on the programmer how he is implementing. Okay, so the priority can be from starting, or the priority can, high priority can be from ending also. And you can say, take it as, like if you consider this example, but we are P1 is having priority 3, and P2 is having priority of 1. So we are considering here priority based on the numbers, that is 1, 2, like 3, 4 and all. That is, we can see the priorities are on like ascending numbers, not on descending numbers. Okay, so all the processes are present in the ready queue. All these processes, they are in the ready queue. They're waiting for execution, or they're waiting for running. So based how the scheduler will choose which process to select. So which is having the lowest priority. So according to our criteria, so 1 is the lowest priority, and this one is handled by the process P2. So this now process P2 will be getting the chance for execution, means it will be getting the first chance for execution. Okay, and what is the burst time and how much time it wants to execute? It wants 1 milliseconds. It has executed 1 milliseconds. And after that, so which process is having highest priority? Process 2. Priority 2 is there. So process P5 is having the second priority. So next here process P5 will be executing, and the total burst time it requires is 5 milliseconds. So it executes up to 5 milliseconds time period, and it will exit. So next third priority is 3. So that is process P1 is holding the third priority. So next process P1 will be executing, and the burst time is 10 milliseconds. So it executes up to 10 milliseconds, and then it will leave. So after that, which process is having the priority? Next is P3. Process P3 will be having the highest priority. So next is process P3 will be executing, and last is P4. It is having the highest priority. Last P4 is executed. And what is the waiting time for each process? So if you check in the order for process P1, the waiting time is, where is P1? So the waiting time is 6 milliseconds. The waiting time is 6 milliseconds, and the process P2, 0 milliseconds is the waiting time, and for process P3, 16 milliseconds is the waiting time, and process P4, like 18 milliseconds is the waiting time, and process P5, so sorry, process P4, it is 18 milliseconds, and next for process P5, the waiting time is 1 milliseconds, and based on this all waiting time, you can calculate the average waiting time. And the main drawback is of this algorithm is it is scheduling, is starvation of low priority process. So what is the meaning of starvation? Starvation is nothing but they will be in waiting stage for long time, or in general English, starvation is called as hunger, as you all know that. Okay, suppose by considering, if we consider this example only, like a process P4 is having, if we take this example, so this here process P4 is having burst time, it is having very low burst time. So if it wants just 1 milliseconds to execute the program, it wants just 1 milliseconds to execute the program compared to process P1 and P5 and P3 also. Okay, so to execute this 1 millisecond, so it has waited up to 18 milliseconds. So at 18th millisecond, it has got the chance to execute or utilize the CPU. Okay, this is called as starvation, means it is just in waiting stage. Okay, if other processes are there with the different priorities, means again this P4 would have been in waiting stage. So here this priority scheduling algorithm, it only gives the importance to the processes which are having the highest priority. Because of this, the process which are having the lowest priority, like they will be suffering from the starvation. Okay, I hope you all understood the concept. And in the next class, I'm going to explain the different concepts. And thank you.